Yeah, so hello everybody. We are going live pretty shortly here, and also thank you so much for being a little bit patient. So we're going to do so. And in the meantime, I'll just open the desktop audio here so you can hear what they're what the commentary from the Rocket Lab. You can hear it in real time. So yeah, we'll go real live soon.
X2 within the Mid-Atlantic Regional Spaceport. The team behind me are getting ready to go for our latest hypersonic test launch for the DIU. It's a crisp 40 degrees out here at the pad, where our launch technicians run through a full day of launch operations before liftoff. Starting from about T-minus 9 hours, we work through general pad system setup before we connect HASTE Stage 1 umbilical. That's the critical power line that connects the rocket to our ground support system all the way up until just before liftoff. At the same time, just a few miles down the road, our launch operators check in to their consoles in our Mission Control Center. Once those early checkouts are complete, the team takes HASTE vertical just a couple of hours later and run an igniter test sequence of the Rutherford engines, making sure the propulsion system is fully primed and ready for the launch ahead. In the hours that follow,
Okay,
the team
so
load the
we
rocket with its
can
kerosene
go,
propellant, as
and
well as
while
run
they
checks
are
across
still
our ground
speaking,
stations
so
and
let me
avionics
go there.
before we get into the lock system
Uh,
show and load sequence
and
at
anyways,
around 3 hours
you have
before launch.
got some of the
The
idea
range
what
safety
they're
status
talking right now.
comes in around 60 minutes
So
and T-minus 30 minutes before launch. And
okay,
then we move into
so
the
I'll
go,
just
no-go
disable
phase
desktop audio
with the
for now
launch
so you can hear
director
my
at
voice.
T-minus.
Okay, so hello everybody, and good morning here in Sarawak in Borneo right now. It's almost 5:39 a.m. here right now. It's 28th February 2026. Yeah, I know, not the best time. It's around, yeah, I should not stream anything at this point, but can't help that much. But fortunately, it's not going to be that long because this is a suborbital flight. If I remember, ST actually stands for Hypersonic Accelerate, Accelerator Suborbital Test Electron. So it's not going to be that long. It's going to be a few minutes into the flight. Only first stage, from what I read, actually, only first stage will be used in this flight. There is not going to be second stage or or another upper stage, the kick stage. That's not the focus for this flight. Yeah, but anything can happen as well. You know, sometimes maybe even customer wants second. Uh, Sometimes the customer wants second stage, so sometimes second stage will also be used, but in this case, only first stage only be used upon the customer's request, especially hypersonics and also DIU, the Defense Innovation Unit. So that's why we only see first stage for today. So uh, while we are waiting, why not we just go straight into the live here? It's almost T minus 10 minutes here, and by the way, we are at least in Borneo right now. It's in Sarawak right now. It's almost 5:40 a.m. Okay, it's 5:40 a.m. 30 seconds. So yeah, so let's go. All right. So I need to remove the replay. Yes. And let's go. I'll focus into the video itself. Where is the here? That that took me a little bit of time, but it's okay.
Is our HASTE vehicle, which flies well beyond that and is capable of velocities all the way up to Mach 20.
Now that opens up a range of test capabilities for mission partners like the DIU and Hypersonics, where thermal properties, tracking, and control can be tested in real hypersonic flight environments, which can't be replicated on the ground. And that's
Okay,
exactly what
that
today's
took me a little
experiment
bit.
is all about. After it launches off the pad, our HASTE rocket will boost Dart AE to
All right.
hypersonic speeds before it's
All
released
right.
horizontally to free fly
How
on
about
its own under
here?
aerodynamic control and scramjet propulsion.
All right.
Now, HASTE's out of the
It should be
box
good.
hypersonic
All right.
capability is
Should be
being
good.
well leveraged for higher cadence and more affordable hypersonic test flights. And today's launch is our fourth hypersonic test mission in under 6 months from LC2, which is exactly addressing the needs of what the US government is looking for, with more frequent and reliable flight
Oh.
opportunities to develop
Under
hypersonic
6 months
capabilities.
since the last
So here's
flight
more about HASTE.
The
from
world is
the
accelerating, and
Mars.
so are the threats we face.
Okay.
Escalating geopolitical tension has revealed a critical defense capability gap, a challenge
Okay.
defined by Mach 5
So
and beyond.
here you
the
can
speed
see
of
the
hypersonics.
logo itself. You can
The
see.
threat is very real. Time is of the
And
essence.
also
if the
there's
adversaries,
something
if the great power
interesting
competition
that
states
I
are developing
actually
this type of capability, we need to
there's
have
something I learned
defensive
a
capability
little
to
bit about the
protect
HASTE
US
itself.
and our assets overseas. Golden Dome at its
Okay.
essence is a
So hopefully
missile
this is
defense
okay.
technology. It is
Okay.
to protect the US
There's something
homeland
I
from
actually
threats.
learned about the
You don't want the
about
first
Rocket
time you
Lab.
try that out
Yeah,
to be live
really.
fire
Originally,
when everything
they
is on the line.
when Sir
For
Peter
decades,
Beck
America's
actually
approach to testing these critical
um,
capabilities
actually
was plagued by high costs and
actually
slow
founded
cadence.
the
status
Rocket
quo
Lab.
was
It's
simply too slow for the
it's
scale of the
actually
threat.
really located
Historically,
in
the
New
programs
Zealand,
have
but
been many years in
however,
development,
at
so
some
think
point
thousands and thousands of engineering
into
hours over a
into the
2-year
company's
refurbishment
lifetime
cycle for these old
because
peacekeeper
how do I say
missiles,
because
a new
they
launch campaign, and a new payload
because at
development,
some point
plus
they
all the
really
downrange
received
assets from hundreds of millions of
US
dollars,
government
and you
money,
get
you know,
one launch.
especially with the NASA
The
and whatnot.
mandate was
They
clear:
decided
lower the
they
cost
they just
barrier and
move on to
dramatically increase the
they
launch
just
tempo.
move the
To answer this
main
challenge, Rocket Lab
office
engineered the
location
Hypersonic
to
Accelerator Suborbital Test
yeah.
Electron,
So
also
that's
known
actually
as
what
HASTE.
HASTE.
HASTE is a converted
Yeah.
electron into a suborbital platform for testing research
Yeah, but
payloads at
I
hypersonic
pronounced it as
velocities.
HASTE,
The heritage
while here
systems
it
have all been
pronounced as
solid-fueled bottle rockets. You
HASTE.
light them and they go.
I
Here,
like to
we can
use
throttle,
HASTE
we
because
can
why
gimbal,
not?
we can get into Mach 20s with this platform, and all the way down
Oh,
to Mach 7.
okay. So
Based on the
apparently
flight
this is another
proven
one here.
liquid-fueled electron, HASTE is fundamentally different.
Oh,
It gives testers
yeah, you
unprecedented
can see here.
control over flight profiles and environments. We can also do very interesting things like offload propellant, vary the exit velocity so we can go faster or slower. We can target downrange positions for payload release.
And
This unique platform immediately shattered the industry paradigm, moving testing from a single launch per year to the speed of commercial production. The predominant
AKA
bottleneck is
you
launch
can
availability. We've
consider
shown that
Electron
going from
rocket
one launch
as
a
a
year,
as a
hundreds of millions of dollars to
Swiss
multiple launches a
army
week. We
knife
did
of
2 HASTE launches in
Swiss
basically a
army
week
knife
and a
of
half.
rocketry
That could have been
nowadays.
years between testing, but instead it was
Quite
back to
there
back.
now because
Leveraging the
it
flight
can be
heritage of
it can be
Electron,
used
HASTE
either
offers
both
a
for
reliability and
orbital rocket
repeatability
launches
unmatched
or
by any
if
system
you
in the
want
world.
suborbital
Electron's
launches or
launched over
sounding
70
rocket
times
launches.
now. It's
You can
very
also
well
go with
understood. It's
this
very high
option,
performing.
which
At commercial
what we are
speed
looking
and
right now,
scale and
the
price
Hypersonic
point, I don't think
Accelerator
anything's ever existed like it.
Suborbital
Hypersonic defense systems cannot be
test
left to chance.
Electron.
The ultimate
So
goal of HASTE
that's
is to
what
provide the data
HASTE
needed to
or
secure the
some
reliability of the nation's
would
protective
also
shield.
going to pronounce it
Space-based interceptors
as
is
HASTE
a
actually
completely unproven
stands
technology,
for.
but it's
So
critical to the Golden Dome
that's it.
architecture. So the ability to test these defensive systems is crucial. It has to be
Alright.
affordable and it has
So
to be high cadence. So that's what HASTE provides. We can go fast, we can
yeah.
go affordably, the full soup to nuts capability. So that's production,
Okay.
that's logistics,
I
it's a
hope this
well-seasoned
is
launch team,
sounds good.
it's launch infrastructure like a launch
Okay.
range, but you gotta be able to put it
Because
all
I don't
together.
want
You
it to
can't name
sound
another flight test
too
platform that
small,
is
so
launching as
hopefully
repeatably,
this is good.
as
Okay.
reliably or affordably
Yeah,
as HASTE
just
is,
like I
and that's
discussed
what's really changing the game in terms of
discussed
getting more data
previously.
sooner. Me and many other people working the HASTE program are very proud to be
Okay.
working on something that
Maybe
leads to deterrence and in a bad day will protect the lives of American citizens.
okay, so that's basically it. Yeah.
At T-minus 5 minutes on the clock, we're coming up now to the final few moments on the pad for That's Not a Knife. But before we get
Alright.
to the launch
So
auto
that's
sequence,
what we are
today's
hearing
flight
right now.
profile is going to be a little bit different to the
Less
orbital
than 5
Electron
minutes
missions that you're
before
probably used to
before
watching.
liftoff.
While those launches
And
usually
then yeah,
reach their
after the
target
liftoff,
orbital
if
velocities
they
and altitudes
decided to
after
they
9
want to
minutes
end
of
the stream
flight,
pretty early
HASTE's
as
mission
well,
will be complete
well
within
maybe
less than a third of that. Now, at the request of the customer, you won't see the staging events between the vehicle's first and second stages, or the shutdown of the 9 Rutherford engines
So
at main engine cutoff.
In fact, soon after main engine cutoff is when HASTE's mission will end, Within fractions of a second after MECO,
Oh,
HASTE's fairing will separate and Dart AE will be
yeah.
deployed.
And
And
also,
we won't hear it across the
from
nets
what
from
I
Mission Control either,
read on
but
the
we
NASA
will stay
Spaceflight
live on
Forum,
air through those mission
the
milestones
article
to call out when
about
those
this
actions
one,
are expected
actually
to happen
they
in real
actually
time.
have some
And
comparison
all in all,
the
we are
fairing
expecting just
length
over
in
2.5
itself
minutes
and
of
whatnot.
flight
This
time
one is
to
pretty
boost
pretty
HASTE to
long,
hypersonic speed,
especially for
and then it is over to Dart to carry
okay.
out its mission objectives
Pardon me,
for
I have a
hypersonics in
little
the
bit of
DIU.
burping there. Okay,
It's going to
but
be fast
it's
and
pretty
exciting
interesting.
to experience in
It
real
actually
time.
uses a
But
much
first, we have
longer
to enter the
fairing
launch's
there
countdown auto sequence, which starts
uh,
at T
in
minus 2
comparison to
minutes to
typical
liftoff. At that
typical
point, the
Electron
HASTE
rocket
rocket will
launchers
switch to internal
and
power
whatnot. You
and
can see
take
it's
over control
pretty
of the
long. It's
countdown.
around,
At the
I
same time,
think,
its launch safety
based
system
based
will
on
be
my
enabled, and
eyes,
Mission
it's
Control
around
will call out both of
almost two
these actions
times
across
longer
the nets.
the
A few moments
than
later,
it
the
is.
rocket's
So
liquid
yeah,
oxygen propellant loading should be complete.
and
And that's another
and
milestone
just
we
for
can
your
expect to hear
information,
from Mission Control.
there's not much
At
else
under 1 minute to lift off, the
coverage,
propellant
live
tanks
coverage
will
that
be
we
at
will
their
see beyond
optimum pressure levels for
beyond
launch.
before the
Ground
MECO
control will
main
then
engine cut
confirm
off,
that the
because
water deluge
afterwards
system on the
it's
pad
going to
is
be
ready to be
pellet
activated
frame
for when
separation,
those engines
and then
on the rocket
and then
ignite.
the HASTE
Then we
itself,
get a
and
30-second
especially
notice to
for
launch
the
before the launch director counts down
for
with the clock
for
from
the
T minus
Dart
10 seconds.
Dart dash
The
AE
engines will ignite at T minus 3
hypersonic test
seconds,
bed
and the launch pad's
plan
hold down
will
mechanisms
actually
will be
going
released
to
for
be
HASTE
tested
to
out,
take
and of
flight
course
at
there's
T0.
going to be a lot of secretive element here and there, because you need to remember this is not just like typical commercial customer flight like that. No, no, no. This one actually also involving US military here. We are speaking about the Defense Innovation Unit, so that's why it's not going to be live
Okay, taking a look at the clock on the
beyond
top left-hand
beyond
screen
the
there,
MECO
we've got
itself,
a
the main
pause
engine
in
cut
that
off.
countdown. So we're going to bring up the audio channels from Mission Control and have a listen.
Okay, so it's currently
LD
hold.
avionics.
Avionics proceed with avionics terminal abort checks sequence 73
Copy sequence 73 in work.
All right.
and stage LD on countdown. LD stage. Stage proceed with the terminal abort checks sequence 74. Copy and back.
Okay, so still proceeding
And
with the
precision
checks.
LD on countdown. While the operators are working on their terminal abort checks, we'll be working on the recycle sequence.
Okay, so they are going to recycle back
Vehicles
for
on
the
external power.
launch sequence. Okay, okay, it's now no longer in the internal power again. So already we connect back, reestablish to the
We've entered a
ground
hold at T minus 3 minutes for upper
electricity
level winds,
connection.
which we knew was a possibility for today's mission. So let's listen in to see if the clock can be reset soon.
Okay, so let's hear it. But in the meantime, why not I just open up the music? So yeah, we chill a little bit here. Huh. All right, so we're still waiting. That's pretty typical and normal in the flight. But however, for new and existing viewers, hello, hello, and welcome. Welcome to the stream where we are going to witness the launch of, or at least if we don't have any aboard, I mean, hopefully we don't have any aboard. This is just like momentary hold. I hope we don't have that, but yeah, hello, hello, and welcome. You're now watching the first ever publicly live published by the Rocket Lab. Yeah, so okay, I have to force myself to close the desktop audio because could be any copyright infringement there. So let's use music from what I have. Okay. Okay. Okay, terminal stage abort has already complete. Okay. I'm just waiting until until there's no music from Rocket Lab. That's going to be a ground for copyright stuff. So let's not even try provoke that in the first place. Yeah, let's just use this music here. So I'm just going to describe what they are saying here. And then once they no longer use any kind of music, so I'm going to re-enable the desktop audio again. Okay, and we are still stuck at T minus 2 minutes and 55 seconds before the flight, and still waiting for the launch recycle. But at this point, if there's no more big problem, they will go and proceed again with the countdown. And then let's just say if they didn't keep holding for too long, probably I'll also going to finish this stream as soon as possible. And yeah, I'm going to take a little bit more rest, and hopefully we'll see you again for the next stream. Yeah, the next stream will be for the, if I remember, for the Firefly Alpha. That one is for the FLTA 007 flight. That one is no payload whatsoever, but there's going to be, on the first stage at least, there's going to be some of the block 3, yeah, sorry, block 2 prototype. There's going to be a Firefly Alpha block 2 hardware validation prototype, where there's basically like a new set kind of guidance, probably new kinds of computer guidance and what's on IMU, yeah, whatever needed to be tested on the block Firefly Alpha block 1. Yeah, right now for the Firefly Alpha right now rocket itself, it's already being retroactively called as block 1, so I'm going to refer it as block 1 for the original rocket. And then for the second iteration of the rocket itself, with, if I remember, it says almost 7 foot, aka almost around 2 meters height changes there. There's basically another slew of upgrade we don't know, but that's it. We are going to see that soon on Sunday. On Sunday at this here will be on 1st March 2026 at 8:20 a.m. 8:50 a.m. here local time. At least back there, it would have been around 8:50 p.m. if followed the if I remember, Pacific Standard Time or Eastern Standard Time. Yeah, EST if I remember correctly. But back in the Vandenberg, it will be around. It would have been around 7:50 or 6:50 p.m. there. So yeah, we are going to see that soon. Back then, it would have been at around Saturday, 28th February 2026. So yeah, it's early morning here, so we're still waiting. And yeah, what I want to say again, so for new and existing viewers, hello and welcome to my channel, and welcome to this stream where we are still watching on the first publicly live by Rocket Lab of the hasty launch. That's not a knife mission, carrying the Hypersonics and also DIU's DART-AE. For the DART abbreviation, there's no publicly available abbreviation of that, but I speculate it could have been something to do with defense accelerator reentry test, something like that. It could have been that abbreviation, but I cannot confirm. But what can be confirmed is that AE actually stands for additive engineering. So we are going to see that pretty soon. But still holding, not 100% sure what they're holding for, because other than they said terminal about something like that, there's not much else information actually known so far, and there's nothing to describe here. That's why I can use my music here, okay, because I want to avoid any possible copyright there. I mean, last time I did that with okay, so apparently ground launch is on the way to process and resync back again into the countdown. That's actually from my understanding that I heard again. Okay, so we're still waiting here. And yeah, just for your information, while we're still waiting, why not I show you a little bit about what they are doing, right? It's not going to be that long. We are going to learn a little bit about the about the hypersonic testbed itself. So let's go. We sit back from the replay. Okay, so here you can see. Oh, sorry.
Hypersonic speeds. This innovative design is part of Hypersonic's mission to
Okay,
create a
so
low-cost,
here if you want to know about
hypersonic aircraft for
about the
applications in defense,
about the
aviation,
Dart-AE,
and aerospace.
the
And
hypersonic
now, here's
testbed,
more from Hypersonics about
the
Dart-AE.
hypersonic testbed plane itself. So you
The
can
time
see.
is right for hypersonics. The purpose of hypersonics is to build and fly hypersonic aircraft. We are out in front in terms of our scramjet technology, so the propulsion, but also our vehicle designs.
We believe it's going to change the way we fly. It really is about that technology as much as the application of that technology.
The other great thing about the scramjet tech that we use, it's air breathing and it uses hydrogen as fuel, so we're not creating any pollution.
What we develop here will have wide-ranging applications across aerospace.
We have this long-term target of flying at Mach 12, and at the moment, Mach 12 for sustained flight, it's kind of in the realm of science fiction. So what we need to do is break down that path to flying at Mach 12 into discrete milestones. The first of those milestones, the first flight activity that Hypersonics is going to perform is DART at Mach 7.
When you travel hypersonic, the main issue is heating.
DART will be glowing red hot and 1,000 degrees, but we have to keep the sensitive electronics on the inside at under their maximum temperatures, and we don't have very much space to do that. DART is a demonstrator to fly at hypersonic speeds, but it's also to collect data and to learn so that we can keep pushing forward and make vehicles that travel up to Mach 12.
The thing about flying fast is you always end up with a really cool looking plane. We've developed this scramjet technology and hypersonic vehicle technology over the last 30 years. So it's come together, it's very mature. And then we have all these other opportunities of new materials, the commercial off-the-shelf hydrogen tech, and the computing power that we use in our analysis.
We've got the best partners on the planet to help us do that. We're dealing with partners such as Hypersonix-DIU and Rocket Lab.
We also have a lot of smaller companies here in Brisbane, but also throughout Australia that help take our tech from the design to the real physical thing.
In order to fly at Mach 7, we need to overcome a whole bunch of engineering and materials and technology challenges, and what we're working on at the moment are tackling those challenges one by one.
We've got the team, we've got the technology, and we've got a way of being able to build what we build in a high cadence. And I think that's why organisations like the Defence Innovation Unit, that's exactly why they deal with people and companies like us, because we can move a lot faster.
The goal at Hypersonics is not just to enable hypersonic flight, but to commercialise it for everybody.
It's for the planet. I think we're building a platform using hypersonic technology, particularly scramjet, that are hydrogen powered, and we're looking to deploy that technology across various aerospace applications. We see the planet as the beneficiary of what we're doing in the longer term.
Launching Dart-AE.
Okay, so that's basically what we learned so far about the hypersonic testbed plane itself, the Dart-AE. So as you have already know, the Dart abbreviation itself never addressed or even mentioned, but that's why I said I speculate it could have the Dart itself could have been something to do with defense. The Yeah, it could be something like defense accelerated reentry test, or it could have been defense. Um, yeah, it could have been also been defense um aero vehicle reentry test, something like that. It could have been like that, but yeah, since that abbreviation did not mention, since there's no mention about the dart full name, so I can only give slightly my speculation based on my guesstimate so far. So yeah, that's it. And so far looks like they decided to just recycle it back to T minus 16 minutes, but however, there's not yet any terminal countdown release yet, so still waiting. Okay, and yeah, that's not much else we can even discuss here, other than you need to know there's going to be only first stage here in this flight, instead of like second stage and even upper stage like QE or even hyper QE. That's not something we're going to see here. Yeah, it's not going to be something here, because you need to remember that haste or hasty, it's not a this specific Electron rocket variant. It's not designed for orbital insertion. It's only just for the suborbital slash sounding rocket application only. So in this case, it's not obviously not going to reach to orbit, but it shall achieve achieve space insertion rather than orbital insertion. You know, you've got what I mean, because going to space, at least for Rocket Lab, it's pretty easy. But however, going to orbit would be something else to even mention about. And so far, from what I do know, is that this is Rocket Lab's first publicly live stream launches of the haste or slash hasty rocket. So that's that. We are still, this is the first publicly live stream of them, so good on them as well. And yeah, so far because there's not much else I can even discuss, probably maybe other than
Looking through checks to determine a new T0 based on evolving weather data. While we wait, we thought we'd take a look back at all 21 of last year's liftoffs in what was a record year for us. Join us with a quick walk down memory lane.
they're instead opening up with this one.
3, 2, 1.
Okay, so we are instead just just watching the visual here. Okay, so I'm not going to open up the music any longer. There's going to be copyright stuff here, obviously. Okay, we are still waiting here. Still holding. Okay. Okay, this is basically like so far what's their achievement with the mission from time to time. Yeah. So I can say it's pretty straightforward. I don't have to tell you anything else here. Especially including, you can see for the escapade, for the dual escapade spacecraft there, or also apparently to be exist there. Yeah, it's a pretty rumbling sound there. Rumbling sound of the rocket launches, but don't worry, you are not missing that much. Just yeah, it's actually interesting to see like this. You can see there. And if I remember correctly, from what you can see on the rocket flame itself, that one is actually propelled by the Carolox propellant. And of course, as you can see visually, the look itself is pretty much uh,
25, a massive year for the team, and we are looking forward to making this year even bigger. And today's launch will be our third
okay.
mission for 2026, with many more booked after this. But back to today, the wind is tracking down, which is exactly what we want to hear, but we're still waiting for that new T0. So let's keep the nets up so we can hear that call out from the launch director.
Okay, so the reason why they are still holding is actually related to the weather situation there, and apparently the wind itself, probably the upper atmosphere wind has already been easing up, already break down into much manageable speed, because you need to remember that uh, for the most of the flight itself, let's just say if there's some wind that actually literally just disrupting the entire whole launches, even if it's like slightly more than what it can tolerate, let's just say if it reaches max Q, it's probably going to destroy the rockets and the payload inside it. So that's why they have to be very careful, because you need to remember that this this rocket, basically Electron rocket, and also this HASTE rocket itself, this one is for the most of the part, you can see the rocket body itself, it's basically a carbon reinforcement built there, aka we like to call this as carbon fiber built there. That one is pretty sensitive to most of the direction, except if it's designed, except if it's like wrap and even designed for specific path of launch. For the most of the time, it's pretty sensitive. Okay, so that's why Rocket Lab has to be very careful about these launches. If the wind situation there, if they decided they just want to go launch it like that without proper consideration, probably they're going to destroy this rocket, and they're also going to destroy the customer's payload as well. In this case, which will be the Dark-AE hypersonic test plan. So that's why they are very very careful here, and they are still looking at the weather situation here. So that's why. Okay, and so far there is not much else we can even discuss here. Oh, maybe another one I can also discuss would have been the rocket engines itself. Maybe if some of you might not know this, but the rocket engines itself, it's not kind of like typical rocket engines there. It's basically powered by battery, and specifically with the battery itself, what it does is that it uses the chemical energy, or probably like battery energy inside it, to actually spin up the DC motor. Yeah, that DC motor is basically okay. So looks like they are still waiting for the countdown. Still waiting for the suitable time. Okay, but I almost forgot to mention this one, that just to go back to what I said, is that instead of, let's say, it's the rocket engine uses the typical turbo pump, okay, just to pull out most of the propellant, the liquid oxygen, and also the super refined kerosene, specifically for the rocketry. Instead of just using like turbo pump, which will be very very heavy, very complicated, and possibly also too much parts to be built that could have been much more prone into failure. For these rocket engines, instead they swap it with DC motor brush and also battery to just to move that DC motor there. That one is basically a replacement for the turbo pump, of course. And as a result, at least for this launch, for the rocket launches, as far as I know, Rocket Lab with their Electron rockets basically became the first in the rocketry history ever to actually uses the electric pump fed rocket engines there. Yeah, the first in the application itself. Back around 2017 or 2018, if I remember, depending on what do you want to count. You want to count the first unsuccessful launches, or you want to count the first successful launch. Either way, Rocket Lab still makes their history undisputed, of course. Until this day, pretty much undisputed in the electric pump fed rocket engines rocket engines arena there. So that's that you need to know. And for the most of the build itself, you can see obviously it's they are using carbon fiber because because why using carbon fiber? Because it's much more lightweight for the launches, and especially, let's just say, where mass are pretty important. You know, the just another word we like to say weight, but something to do that's not really tied to the gravitational pull of Earth. So we are going to use the word mass here. Of course, every mass saving, you know, every weight saving is pretty important, because if you can trim down even just slightly little bit, it can be the difference between launching it to the another higher orbit, or it can only just do it with reduced payload capacity, or maybe you have to sacrifice where it can go. Or let's just say, one of the best way I like to mention it can be the difference between going for interplanetary mission, going for deep space mission, or it's just going to be stuck forever inside the Earth's orbit. So that's why every mass saving is pretty important. So they try shave it as much as possible, and as a result, they uses carbon fiber built here for the mainframe, for the airframe of the rocket, for the Electron rocket, and also for its suborbital variant, which what you're looking right now, the HASTE slash as I like to call it, hasty rocket. So yeah. And yeah, it looks like we are still waiting. And yeah, I also forgot to mention that the rocket engines itself is actually, most of the manufacturing stuff, it's actually uses 3D. It's actually 3D printed, so there's not much else involving anything with a lot of manual production and whatnot. Maybe only thing that it only needs probably some small amount of soldering, maybe even small amount of welding, but most of it would have just been automation anyways. So it's pretty useful, so to speak. And yeah, we are still waiting in the launch pad. Specifically, this one is from the Mid-Atlantic Regional Spaceport. This one is located around Wallop's flight facility area. Okay. And of course, when I hear the way I'm speaking right now, obviously I've got tired because I'm waiting for the hole itself. Okay, so maybe if you'll excuse me, maybe you can let me rest a little bit. I'll give a little bit on the text or what what would like to say. Hmm? Oh. Okay, so here you go. Okay, so I'm going to take a bit of rest here, just closing my eyes and just waiting. So yeah, if you see my avatar is just like here, you're not that wrong. I'm just that tired for this early morning. So yeah, so thank you. We'll be back soon again.
System mechanisms armed.
Oh yeah, I forgot. I actually turned off my mic here, so uh, it's okay. So hello everybody. Just as
We are
promised.
now at T-minus 4.5 minutes, and shortly we will have to enter the launch's countdown auto sequence, which starts at T-minus 2 minutes to liftoff. That's when the rocket will switch to internal power and take over control autonomously. A few moments later, the rocket's LOX propellant loading should be complete and in recirculation.
Then again, at under 1 minute to lift off, the propellant tanks, will be fully pressurized for launch, and our ground controller is ready to be activated for when those engines ignite. Then it is 30 seconds until launch before the LD starts to count down with the clock from T-minus 10 seconds. It's full noise at T-minus 3 seconds when those engines ignite, and then the launch pad's hold down mechanisms release for HASTE to take flight at T0.
We're going to bring up the audio channels now for Mission Control to listen along to those milestones in real time. We'll be back with you shortly after liftoff for those 2.5 minutes of hypersonic flight for That's Not a Knife. Go HASTE, go DIU, and go Hypersonics.
Yeah, so that's it. We have heard it. Okay. And yeah, just like as promised, at T-minus 5 minutes, I've already woke up again, and looks like we are ready right now. At right now,
And
T-minus
stage
3
launch,
minutes
we are
mark.
3 minutes and counting. At this time, the 3-word procedures is in effect. From now on, there should be no red flags on your critical LCCs. VCON LD on countdown.
LD beacon.
Holds. Oh,
The count has been held.
Yeah.
Hold.
okay. Hold again. Oh my, unbelievable. We are holding again. What's happening here?
That is a hold on the countdown clock. We are paused at T-minus 2 minutes 56 seconds to lift off. So let's wait to hear for an update from Mission Control.
Confirmed.
GCLD on countdown.
GC.
GC confirmed the stage 1 and stage 2 umbilical status are engaged.
Confirm engaged.
Copy and please proceed with the secure LB on path and enable ECS.
Understood work.
Thank you. Avionics LD on countdown.
LD avionics.
Avionics proceed with avionics terminal board checks sequence 73.
Copy and work.
Stage LD on countdown.
LD stage.
Stage proceed with stage terminal board checks sequence 74.
Copy and back.
Oh, because
Vehicles on external power.
okay. Okay, so let's check again. Okay, so it's open until what? Until how many minutes? Oh, it's go the window until 8:45 a.m. Oh, you're still holding, yeah. All right. I wonder why. Okay, let me open the music here. Let's see what they are going to say. Are we going back again at T-minus 16 minutes? Oh man, it's already morning here right now. And let's just say if they didn't manage to open this, if they didn't manage to launch until around 1 hour and 15 minutes from now, they have to scrap the entire whole launches, and they have to bring this to another day. Could be for tomorrow.
Stage mission.
Okay, could be for
Stage
tomorrow.
Stage
Okay.
LD.
That's the stage terminal board checks complete.
Copy, thank you.
Alright, so could be they have to cycle it back for tomorrow launches or anywhere launches, but let's hope they will launch it for today, you know? Yeah. Looks like we are still
LD
waiting.
avionics on countdown.
Avionics LD.
Avionics terminal board checks complete.
Alright. Terminal abort checks
Copy.
complete. Okay, this is just like previously. I don't have to mention this stuff. Okay, but all we can do is just keep waiting and keep being patient anyways. This is pretty typical on rocket launches. You will unfortunately going to experience this lots of time, but yeah, I hope you already know it. But if you're new, that's literally the spaceflight rocket launches in general. It's going to be delayed like this. So yeah, I hope you guys can take a little bit of easy there, you know. And maybe in the meantime, I'm still going to wait again, you know. I'm going to do something else meanwhile, yeah, because I would like to prepare to go to church. Yeah, it's already at least in my time right now, it's around almost 7:32 a.m. here. Okay, mark 7:32 a.m. here, so it's morning, so it's appropriate for me to actually go ready and prepare to go to church. So rather than waiting for too long, I'll just let this open in the background, and I'll just update this in the text here. You know, let's just wait. But in the meantime, there's nothing wrong in even just having this text. You know, I'm going to write it here. Okay. Okay, so here we go. Yeah, unfortunately, this is the situation we're dealing with. Okay, so yeah, I'll be back again. And yeah, there are possibilities of the abort until tomorrow or anywhere around the time, but I hope we are able to launch it for today, you know. So I don't have to go stream at late night, late morning. Yeah, I mean early morning. I hope I don't have to do that, but yeah, it's okay. Let's be patient. And in the meantime, I'll just close the desktop audio just in case there's any. Oh, okay, looks like we are cycling back again, and we are targeting for the launch half an hour from now. Yeah, so it seems like that. Okay, but in the meantime, I'm still going to prepare behind the scene. I'm not going to wait for too long, because otherwise I'm not getting anything good for prepare, you know. So yeah, please be patient a little bit for me. I hope I'm not going to take shower for too long and not preparing for too long as well, because I will go to church
Okay, once
eventually.
again, that clock
So,
at
yeah.
the top left-hand corner of the screen has restarted, counting down to the final opportunity in today's launch window. We are, however, still waiting to hear the confirmed new T0 time from the launch director, so we're keeping up the audio channels from Mission Control, waiting to hear that call from her hopefully soon.
Okay, so it looks like the terminal count here it's not final there, but they still have the chance until at some point. Let's go with here again. If we actually change it into
GC on countdown.
GCLD.
Vi secured the pad, ECS is new.
Copy.
okay, let's just say, can I actually change the time to? Oh, never mind. It's actually uses still stuck here. Never mind. But like I said, in our local time here, it's it's almost 7:36 a.m. here. So they have less than 1 hour and 10 minutes before the launch window close here. So if the launch window close, they have to bring these launches back into possibly by tomorrow at the earliest opportunity. But hopefully it's not the case, because we're still waiting here. Yeah, I know it's a bit boring. Yeah, but that's pretty typical. And yeah, just like I said, I'm going to be back again soon enough, just in case the launch window happens to be through, not something gimmicky there. I've already ready to stream, you know. So hopefully we'll be back again. Hello, everybody. So looks like we are returning back from lunch, and yeah, I do have some a little bit of refreshing shower this morning. So fortunately, you know, when you shower, it actually feels good. Just as feels good as this. All right, awesome. So looks like we are still proceeding. Okay, still green board. Green board. All right. 30 seconds. Okay. 30 seconds before the HASTE rocket onboard computer guidance system finally fully gone automatic on for the sequence of the flight. 15 seconds. 10 seconds. Mark. And getting ready for 5 seconds. Mark and getting ready for the auto sequence start. Mark. So auto sequence start on the onboard flight computer instrumentation inside the HASTE rocket itself. Alright, so looks like green board for the launch. And we are getting ready in. Okay, and awesome. And prior to liftoff around T-1 minute or maybe 30 seconds, I will switch the music to turn off. Okay. Okay, lock slot has already complete. And now, no more refilling as the launch still proceeding to continue after hours of delay, but fortunately that's all is good and it's nothing to do with the HASTE rocket itself, rather is the situational weather condition surrounding the launch area itself. Okay, T-1 minute mark, and we are getting ready, and I will also going to turn off this music as well, as I'm also checking out from my music system here, multimedia system. I don't know, that's fancy word, isn't it? Okay. Okay, T-minus 40 seconds. And getting ready, count on at T-minus 30 seconds, and then I will turn off my music. Mark. So 30 seconds, and now we are in fully turned on right now for the launch itself. So getting ready and be prepared. T-minus 15, 14, 13, 12, 11, 10, 9, 8, 7. Okay, getting ready for the liftoff. Ignition of the 9 Rutherford engines, and liftoff. We have liftoff of the HASTE rocket launching from the Mid-Atlantic Regional Spaceport from the Rocket Lab LC2 Launch Complex 2, also known as the LP-06 Launchpad 0C, and we have liftoff for the mission. And here we go on the first flight stage, and I think by now should be getting ready. Okay, Mach 0.5. By now, Rutherford rocket engines should have already throttled down to 60% as we are getting ready for as preparation for the supersonic. We shall hear the call of the supersonic. Okay, by now, supersonic. And okay, getting ready for max Q. Max Q. Oops.
Cleared max Q.
Okay, so we have cleared the max Q.
A nice
maximum
clean sail
aerodynamic
from
pressure
Max Q by HASTE now
on the
at speeds of more than 2,000
on the mechanical
kilometers an
stress of
hour.
the rocket
Hearing
itself.
good calls from mission control as well. High voltage battery discharge should be happening as we need it to for those 9 stage 1 Rutherford engines at the bottom of the
All
rocket.
right.
And coming
So
up
looks
soon
like it.
will be MECO, or main engine cutoff of those engines, which is when all 9 of them power down at the same time. And now usually
Okay.
that is to allow for the first stage to separate from the second, but with this experimental hypersonic mission, we are doing things differently. And
Yeah.
so at about the same time as
So
those
that's
engines
it.
shut down,
What we're
HASTE's
hearing.
fairing will separate and DART will be deployed to begin its free flight at hypersonic speed.
A reminder that at our customer's request, we'll be cutting the camera view just before MECO, fairing separation and payload deployment, but we will mark the moments we're expecting those actions to take place before
Oh
DART
yeah,
AE
as you can see,
flies the
it's
rest of
already
the mission.
tilting
So
off
let's watch and
to the
listen
side
now.
right now
Stand by for MECO.
and getting ready for the MECO. Main engine cut off, and then prior to this, we will see the live feed will be cut off as the experiments begins. And of course, because there's tons of secrecy behind it, and also even including some pattern. Okay, we have seen it cut off. So here you go. Let's hear in for the confirmation of the MECO.
Okay, and with the clock now past 2 minutes and 45 seconds into flight, that marks our expected main
plus
engine cutoff,
3
fairing
minutes.
jettison from HASTE, and deployment of Hypersonics DART AE aircraft at hypersonic speed to continue on with their mission.
Right now, the
So
team
that's
will
it.
be testing the aircraft's aerodynamic
Not much
control
else we
at several
know about
times
this
the
one.
speed of sound, as well as its scramjet propulsion to power the vehicle along its suborbital trajectory. Good luck to the DIU and Hypersonics for the remainder of the mission.
So HASTE's role in this launch is otherwise complete. Another hypersonic test launch with 100% mission
Alright.
success out of
So
Launch
success
Complex
again
2 on
for this
Wallops
mission
Island.
of
And
the
this is our
HASTE rocket
second
launches.
hypersonic flight for the DIU in just 3 months, and our 7th HASTE launch overall to test technology in those real-life conditions. This mission is also our 11th overall launch from Launch Complex 2 on Wallops Island within both the Mid-Atlantic Regional Spaceport and NASA's Wallops Flight Facility. So, congratulations and thank you to our launch partners for your ongoing support.
And since we're rounding out with numbers, today's launch is our 82nd launch in total and 3rd launch this year, with our next mission scheduled to take place in just a few days' time. But this time from Launch Complex 1 on the opposite side of the world. Make sure you check out our social
Okay.
pages
So
and
we are
website
not
for
going to
more
be that
info.
long.
Otherwise,
What
thank you
mission
so
could it
much
be?
for joining us for this mission today. We'll see you back here soon. This is Rocket Lab Mission Control signing off.
Okay, so that's it. And now this is the view. All right. So this is the view of the Rocket Lab Launch Complex 2. And that's it. Thank you so much for watching. It says here. But however, because I broke up that that previous part, so as compensation, I will go back to this mission one here. Okay, so here you can hear it on replay. We are going in with the desktop audio here.
T-minus 20 seconds and counting.
Stage 2 tanks are pressed.
Okay, so here's the launch replay.
10, 9, 8, 7, 6, 5, 4.
Here you can see,
3,
this is the replay of the launch itself.
1.
It's from the Mid-Atlantic Regional Spaceport around 6 minutes ago. Here's the launch. And it looks pretty majestic on this liftoff as the Carolocks burning, literally just brightening up this the wall of sky. As you can see here, this is on the first stage view, And then by then, this is before reaching Mach 0.5. And then once it's already reaching Mach,
Stage 1 propulsion is nominal.
around this one, the Mach 0.5, it's
Well,
all,
that's
it,
not enough.
all of
That
the
is our
Merlin,
HASTE rocket on your screen
sorry,
there
not
with a
Merlin, all of the
textbook launch off the
9
pad at
Rutherford
LC2
rocket
on
engines
Wallops
there
Island.
being throttled
HASTE is
down back
climbing
to
faster now
60%
at
as
almost
it
900 kilometers
goes
an hour
for
with
the
an almost immediate
supersonic
pitch over
and
to follow
eventually
today's
to the max Q,
suborbital
which is the
trajectory. Max
mechanical
Q,
stress,
or maximum
peak
aerodynamic
mechanical
pressure, is
stress
up
fully
next.
exerted on
Standing
the
by
launch
now with
vehicle,
mission
on the
control.
rocket itself.
Approaching max Q.
And that one is pretty important because if it fails, well, it's not going to end pretty well. But fortunately, as we saw around 6 minutes ago, the launch is pretty good.
Max Q.
And you can see even there is like
A
atmospheric
nice clean
water
sail
vapor
through
there.
Max Q by HASTE there,
And
now at speeds of more than
there you go.
2,000 kilometers an hour.
All
Hearing
looks
good
good.
calls from mission control as well. High voltage
And yeah, I'm
battery
going to
discharge
replay
should
this
be
until
happening
3
as
minutes.
we
And
need
after
it to
that,
for
we
those
will end
9
the stream.
stage 1 Rutherford engines
Because there's
at
nothing
the
else
bottom
you
of
need
the
to
rocket.
see.
And coming up soon will be
And then
MECO,
afterward,
or main engine cutoff of those engines, which is when all 9 of them power down at the same time. And now usually that is to allow for the first stage to separate from the second, but with this experimental hypersonic mission, we are doing things differently. And so, at about the same time as those engines shut down, HASTE's fairing will separate and DART will be deployed to begin its free flight at hypersonic speed.
A reminder
yeah,
that at our
and as you can
customer's
see,
request,
the
we'll be
launch
cutting
angle
the
itself
camera
is
view just
pretty
before MECO,
interesting,
fairing
and you can
separation
see
and
how the
payload
trajectory
deployment,
goes.
but
It
we will
it
mark the
also
moments we're
yaw and
expecting those
pitch and
actions to
slightly
take
roll
place
there.
before DART
Pretty
AE
interestingly,
flies the rest
because
of the mission.
it does
So let's
need
watch and listen
need
now.
to do a little bit
Bye,
of
Miko.
experiment for this specific customer, specifically for Hypersonics and also for DIU, the Defense Innovation Unit, basically a branch of uh, a US military branch organization there. So that's why after that it's cut off up until there. And yeah, and then after the Miko, not long after that, it's going to be payload fairing separation, and then also the separation of the Dart AE hypersonic test bed plan there.
Okay,
And then
and with the clock now
that's
past 2
basically it.
minutes and
The
45 seconds into flight,
launches.
that marks our expected main engine cutoff, fairing jettison from HASTE, and deployment of Hypersonics Dart AE aircraft at hypersonic speed to continue on with their mission.
So that's basically it. You need to know that's the launch, and yeah, so far it's pretty uneventful. Yeah, fortunately, and that's a good sign because otherwise, Rocket Labs is not in the good situation. But I hope you guys nevertheless actually enjoy this stuff, and thanks for joining by for my to my stream. I whether you are still new viewers here, or maybe if you're existing viewers here, I really appreciate that you really came in here and actually just watch together with me, and also for sort of camping around with me while we are waiting for the launches itself. Yeah, so thank you so much, everybody. I really do appreciate it. And yeah, there is not much else to say here, but we might see another launches soon for tomorrow. Yeah, tomorrow launches, it will be here. Let me show you here. It's going to be Stairway to 7. Okay. Tomorrow's launches is actually pretty interesting because we are going to see 2 launches on one day. The first one will be for the Firefly Alpha Block 1. That one is essentially on the first stage. The avionics, all of the systems and whatnot that should have been used for the Block 2 will be tested here. This one for this flight. At tomorrow, at least my place would be the Sunday, 1 March 2026 at 8:50 a.m. And then followed by, not long after that, hopefully we don't have any abort. I mean, even if there's nothing aboard, I hope it's not going to take us too much time. Followed by these launches of the Kairos rocket for the Flight 3. Tomorrow at 10 a.m. here. It's not really that far away. It's just 1 hour and 10 seconds apart. So it's pretty interesting. If the launches did not abort, if the launches did not delay too much, we will make this stream separately. But otherwise, if that actually happens, maybe possibly for you, let's just say if the time is not really super conducive, I will change the title last minute. Okay, last minute title changes, which means, well, also post changes. I will prepare everything as much as possible in first hand, so we are not having this weird stuff, because who knows, the launches can be there almost at the same time, so we need to be prepared with it. Okay, so yeah, thank you so much everybody for watching. As until we meet again for tomorrow, see you next time. Until we meet tomorrow, see ya. And also I need to go to church today, so yeah, good news is that it doesn't take too long. So okay, so and here is my closing statement for today. So thank you so much everybody for watching. This is your I'm Dennis Suguwa, your host today for the launches of the HASTE rocket, or HASTE rocket carrying DART-AE's hypersonic testbed plan for Hypersonics and also DIU, Defense Innovation Unit, which is a US military branch organization. So that's it. That's the only thing we have to see there. So thank you so much. Thank you so much everybody for watching, and take care. Bye bye, and see you soon for tomorrow. So that's it. Bye bye. There's literally nothing else to watch here, and I will also going to update the description there. Okay. And also for the other stream. So that's it. Thank you so much everybody. Bye bye.